Long before humans, before mammals ruled the earth, this was a world of giants. But tracks like these aren't just ancient scars in stone. They're messages from the past, and these signs tell us what it was like to live in the past, and I don't think you would have wanted any part of it. These footprints were left over 150 million years ago. To understand the world of dinosaurs, we need to step back in time during the Mesozoic era, when the supercontinent Pangaea began to split. Land masses drifted apart, creating shallow inland seas, new coastal plains, renewed volcanism, and changes in climate. This shifting geography set the stage for one of evolution's boldest experiments, the dinosaurs, and they were able to populate just about every corner of the earth. Today we're heading back to the Mesozoic, a time that was punctuated by several minor mass extinctions, a sweltering greenhouse climate with low oxygen levels, high carbon dioxide, higher sea levels, and dinosaurs. As you head into the field, you can find signs of dinosaurs on just about every continent. Of the numerous dinosaur species, we'll take a look at 3 dinosaur types to give you a feel of what it was like to find remnants of their presence in the field. Ornithopods, sauropods, and theropods. From this diagram, you can see that birds are also related to theropods. And while we don't always find dinosaur bones, you'll see how their footprints can tell us a lot about their size, behavior, and even communication. We start our journey on the south coast of Portugal, where right on the beach there are massive footprints. Iguanodons were ornithopod herbivores. They were also one of the first dinosaurs to be described back in 1825. And they play an important evolutionary bridge between the early bipedal dinosaurs and later more specialized herbivores like duck-billed dinosaurs that walked on all fours. Okay, I found them. These are the iguanodon footprints. They're pretty darn big. They're the size of probably elephant footprints. The fact that we see them here helps to explain how the fauna distribution shifted across Europe during the Cretaceous as sea levels changed. Next, we'll go further back in time to the Jurassic to visit a quarry with a very dense concentration of theropod footprints. So this is a great little site because these are Jurassic or Middle Jurassic rocks, probably about 180 million years old. And we're seeing our theropod footprints. And there are all kinds of tracks all over the place. And here's a footprint here moving to the left. You can kind of see the 3 toes or prongs there. These guys are related to T-Rex. T-Rex was a theropod, probably one of the larger ones. The smallest theropods we see are actually living today, and the hummingbird is the smallest living theropod. But these theropod prints are probably a foot long from the longest toe or the middle toe to the heel. They actually have a back claw as well. These guys probably existed around, like I said, the mid-Jurassic. One of the things about the theropods is that they had narrow blade-like teeth. They were actually serrated, and so these are very carnivorous, predatory dinosaurs. From just their footprints, we can learn astonishing details. How fast they moved, whether they traveled alone or in groups, even how their weight shifted with each step. These were not slow, lumbering beasts, but many were agile, alert, and adaptive. Among their traits, theropods had stereoscopic vision that enabled them to perceive depth, while some lineages also had feathers. Next, we'll go on to another quarry with some of the longest tracks in the world at 147 meters. The fossil tracks you see here were left by sauropods, massive, long-necked herbivores stretching over 100 feet and weighing 70 tons or more. Dinosaurs were incredibly diverse in form and function. Sauropods evolved lightweight, hollow bones to support massive bodies. Anatomy tells us not just what they looked like, but how they behaved and even what they sounded like. Yes, new research has focused on dinosaur vocalization. As you walk along this trackway, you'll see numerous features in the footprints, such as scaly toes that tell us the direction of travel. We can also see some crescent footprints which represent the front feet, as they put less weight up front and bent their legs while walking through the swampy, shallow water. These dinosaurs are believed to have been more social compared to the solitary hunting lifestyle of some of the theropods like T-Rex. But dinosaurs weren't alone. Shallow tropical seas teemed with life. Corals, reef-building organisms, ammonites, and marine reptiles like plesiosaurs. The reef fossils you see here speak of warm, thriving ecosystems along ancient coastlines. Even with a greenhouse atmosphere and occasional anoxic conditions in the ocean, these marine worlds were biodiversity hotspots, just as coral reefs are today. And just like today, their health was tied to global climate, sea levels, and tectonic shifts. The Mesozoic lasted for more than 180 million years. In the Jurassic, we saw the golden age of sauropods and the rise of feathered theropods, many of them near forests of trees like the one you see here. By the Cretaceous, hadrosaurs and other dinosaurs, as well as flowering plants, were reshaping ecosystems. The world kept changing, and dinosaurs adapted with it, to a certain extent. Just over 66 million years ago, a massive long-duration volcanic eruption in what is now India created climate instability and acid rain. Over 2,500 eruptive cycles led to a slow increase in carbon dioxide. This in turn increased global temperatures. Many species of dinosaurs struggled to keep up with the climate instability and eventually died off. Then one day, 66 million years ago, it all changed. A sudden catastrophe, a massive asteroid impact coupled with the ongoing volcanism, triggered the extinction of most dinosaurs. The impact triggered a massive increase of 5 degrees in temperature, along with the release of enormous amounts of carbon dioxide and sulfur. Some researchers show that large-scale spontaneous combustion in the area of the impact contributed to more greenhouse gases and soot that affected the planet for an extended period, followed by a cooling period. This climate instability proved to be fatal to all non-avian dinosaurs. But not all life vanished. A few small theropods and reptiles survived, evolving into what we know today as birds. Every fossil is a portal, connecting us to a world long gone. Whether it's a footprint or a delicate reef shell, the Mesozoic speaks through stone, and when we listen, we step into deep time.